Good day, everyone. So here we have a problem for the chapter 1, the properties of fluids. The compressed air tank shown in figure E1.3a has a volume of 0.84 feet cube. The temperature is 70 degrees Fahrenheit and the atmospheric pressure is 14.7 pounds per square inch. When the tank is filled with air at a gauge pressure of 50 pounds per square inch, determine the density of the air and the weight of the air in the tank. So, before solving for the problem, we must first determine the givens. So here we have the volume, the temperature, the atmospheric pressure, and the gauge pressure. So to solve for the density, we can use the ideal gas law equation, which is the pressure times volume equal to mass times universal gas constant times temperature. We can just cross multiply these and come up with mass over volume equal to pressure times over R times temperature, where mass over volume can also be density. So from here, we can just plug in all of our givens. Take note that the absolute pressure is equal to gauge pressure plus atmospheric pressure. So here we have the gauge and the atmospheric pressure. Then since the unit that we needed is pounds per feet squared, we then multiply it by 144 inch squared per feet squared in order to cancel the inch squared. Then here we have the R, or the universal gas constant, for the English unit. Then here we must convert the degrees Fahrenheit into Rankine, so we only need to add 460 into 70 degrees Fahrenheit in order to convert it to Rankine. So solving this, we will get 0.0102 slugs per feet cube. Since we can just cancel the pounds here, the inches squared here, and the Rankine here. You can just multiply the feet squared and the feet in order to come up with feet cube, and we are left with slugs over feet cube, and that would be the final answer for the density. For the weight, we have a formula for the weight, which is mass times gravity, where mass can also be equal to density times volume. So we can say that the formula for the weight is also density times volume times gravity. And since we already solved the density, we can just plug it in along with the other givens. Here we have 0.0102 slugs per feet cube for the density, 0.84 feet cube for the volume, and 32.2 feet per second squared for the gravity in English unit. So solving this, we can come up with 0.276 slugs times feet per second squared, because we can just cancel the feet cube here and here. So that will be our unit, and since slugs times feet per second squared is also equal to pounds, then we can say that weight is equal to 0.276 pounds. So that would be the final answer for the weight of air in the tank.